We're going to take a look at adding, subtracting, and multiplying roots. We looked at dividing roots in the last video. Now, roots can be added and subtracted if the root itself is the same. So here we have 3 of the root 5s, and we're adding 7 more of the root 5s, giving us a total of 10 of the root 5s. Roots can be multiplied, so something like this here. Notice everything on the inside is multiplication, and everything in between is also multiplication. So we have multiplication here, and multiplication here. If everything's multiplication, you really don't need the parentheses, so you can just multiply in any order you want. So you put what's in front of the roots together, and then you multiply the roots themselves. So you multiply what's in front of the roots, multiply what's inside of the roots, and you would get this. So that's kind of the main idea that we're looking at here. So here we're adding and subtracting roots. Well, you'll notice they're not the same root. But we could maybe simplify these roots. You'll notice 45, well, that's a 9 times a 5. And I like that because the square root of 9, I know what that is. That's a 3, still with a root 5 hanging around. And that leaves me then with 9, because 3 times 3, of those root 5s. Looking here, I have not 180, but 80. Looking at factors of 80 that are perfect squares, well, that's a 16 and a 5. 16 is a perfect square, so I can simplify that. The 5's not, so that stays hanging out in the root. So the square root of 16 is 4, still with that root 5. So that gives me 20 of those root 5s. Same idea over here with my square root of 20. 20 factors that are perfect squares would be a 4 and a 5. Still that 4 in front like I had before, but the square root of 4 is 2, still with that root 5, gives me 8 of the root 5s. Now you notice at this point, all these have the same roots. So we have 9 of the root 5s, we're taking 20 of the root 5s away, and we're adding 3 of the root 5s, and well, that's just a total of negative 3 of those root 5s. Top right over here, you'll notice what we're doing is we really have 2 terms in the first parenthesis times 2 terms in the second parenthesis, because it's multiplication in between. So 2 terms times 2 terms. That's kind of what we've been doing in the past. Essentially, you're foiling. So we're going to take our 2 root 3 times 3, so that gives us a total of 6 of those root 3's, because we're multiplying what's in front of the roots. Our 2 root 3 times our negative root 3 here for the outer terms. While positive times a negative is a negative, 2 times a 1 is 2. Multiply what's inside the roots, 3 times 3, and that's 9. Then we multiply the inner terms together. A positive times a positive is positive. Multiply what's in front of your roots, which is a 9, and then there'd still just be a root 3 hanging out. Then we multiply the last terms together. Positive times a negative is a negative. Multiply what's in front, 3 times 1, and then you multiply what's inside. 3 times a 3 would be a root 9. Now, we can't do anything to simplify this, but you'll notice that root 9 is 3, so it's a negative 2 times 3. Root 3 doesn't simplify, so we'll let that hang out. And then our root 9, that will simplify again. Well, let's see. 3, or a root 3 and a root 3, we can add those together. 6 of the root 3's plus 9 of the root 3's is 15 of those root 3's. This is a minus 6. This is a minus 9 right here. Well, the minus 6 and the minus 9 we could put together is just a negative 15. This is going to be your answer. Some of you may want to go ahead and pull out a 15 at this point, but that would be parentheses being left in your answer, and it says simplify. Simplify typically means write your answers without parentheses. So with that in mind, go ahead and try to do this second problem on your own after we do this first problem here. There's a couple ways you could do this first problem. You could just multiply what's in front and then multiply what's inside and then simplify. Sometimes it's going to be helpful to try to simplify each root and then multiply. In this case, it doesn't make a difference how you do it, but I'm going to go ahead and multiply what's in front, and then multiply what's inside of my roots, and write it as one big root. Now I'm dealing with a cube root. Want to write the inside as perfect cubes. And the cube root of 64 is just 4. The cube root of my a cubed is just a. So I really get 6 times 4, which is 24. So try this problem and the next couple problems on your own, and then watch the lesson. We can't just go ahead and simplify these roots by adding and subtracting them together because they're different. But we could simplify each root. 75 is 25 times 3. 48 is a 16 times 3. And then we'd still have our root 3. Take the square root of that 25, that's a 5, but we'd still have our 3 hanging out on the inside. Square root of 16 is a 4, but still having a square root of 3 hanging out. So in other words, we get 15 of the root 3's minus 8 of the root 3's plus 1 of the root 3's, and that gives us a total of 8 of the root 3's. Here, we just have to FOIL. So 5 times the 2 root 5 is 10 of those root 5's. Multiply your outer terms together. It'd be a negative 2 of the root 35's, because 35 comes from the 5 times the 7. Multiply the inner terms together, and that gives us a positive 20 of the root 6's. And multiply the last terms together, it gives us a negative 4 of the 42's. Now, once you get to this point here, sometimes some of these roots will simplify, or sometimes some of these roots will be the same, and you can simplify it down. But in this case, it doesn't. Now, up here, we have our root in the bottom. We don't like to leave roots in the bottom, so we got to get the root out of the bottom. Now, if the bottom was a 2 times a root 6, you'd multiply by a special form of just a root 6 over a root 6. But that doesn't work here, because if we multiplied top and bottom both by root 6, yes, a root 6 times a root 6 would just be normal 6, but multiplying the whole bottom by root 6 means we'd have a 2 times a root 6 hanging out here, so we'd still have a root in the bottom. When you have two terms in the bottom, where one of them's in the root, or there are two totally separate roots, you have to multiply what's referred to as the conjugate, where it's the same thing, but the signs are switched. One's plus and one's minus. So if I multiply the bottom by this, I got to multiply the top by this. So on the top, we got to take 3 and distribute it through. 3 times 2 is 6, 3 times our root. Bottom 2 terms times 2 terms, you just have to FOIL. So the 2 times the 2 times the positive root 6, this inner terms, and we do our last terms. Oh, you'll notice the inner terms cancel. Now, just a second here, I want to show you one thing here that you may or may not have seen. We've really dealt with this problem before. If I would write it like this here. Oh, you might say, oh, well, this is 2 squared minus a root 6 squared. That's really differences of squares right here. And you know, differences of squares factors into 2 parentheses that are the same, with 1 plus and 1 minus. And you ask yourself, what's being squared in the beginning? Well, it's really a 2 squared, so you put a 2 in the beginning of each one. What's being squared at the end? It's a root 6, so you put a root 6 in the end of each one. So the conjugate thing that we talked about here really comes from the differences of squares. So the top doesn't change. The bottom simplifies a little bit because the square root of 6 all squared is 6. Put the bottom together. Typically, we don't leave the negative on the bottom. It's not technically wrong, but it's not really common practice. So I'm going to take the negative from the bottom and apply it to the whole top. And we would get this. What do we have here? Is this like a snowman having a snowball fight with his albino friend that's a deer? I think it is.